Good morning, everybody. Last time we have to explain law of reflection, law of refraction, and today I am going to start Snell's law. So, Snell's law, also known as law of refraction, that is sin I upon sin R. So, sin I upon sin R equal to constant. This is the law of refraction. And the statement of law of refraction, when the incident ray falls on the mirror, that ray enter from one medium to another medium with bending is called law of refraction. And here is sin I upon sin R equal to constant. So this is the law of refraction or Snell's law, keeping your mind. Sin I upon sin R equal to constant. This is the Snell's law, and Snell's is the name of scientist. So again I revise this Snell's law. Snell's law states that the ratio of sine angle of incident and sine angle of refraction is constant. It's called Snell's law. Sin I upon sin R equal to constant. So mu equal to sin I upon sin R. Here mu is the refractive index, I is the incident angle or angle of incident, and R is the angle of refraction. So this statement is also known as law of refraction or Snell's law. Sin I upon sin R equal to constant. And in words, it states that, or Snell's law states that the ratio sine angle of incident and sine angle of refraction is constant. So this constant mu is constant, and mu is the refractive index. So in the Snell's law, there is two cases. Number one, light enter into the one medium to second medium with bending towards the normal. Light enter into the one medium to second medium with bending towards the normal, that is sin I upon sin R equal to constant, that is less than 1. And case 2, light enter into the one medium to second medium with bending away from the normal, so that is sin I upon sin R equal to constant greater than 1. So this is the two cases. Both cases are very important for your view of examination. So in Snell's law states that the ratio of sine angle of incident to sine angle of refraction is called Snell's law. In mathematically, sin I upon sin R equal to constant. So sin I upon sin R equal to mu, and mu is the refractive index. This Snell's law shows two cases. When light enter from one medium to another medium with bending towards the normal, so that is sin I upon sin R equal to constant less than 1, so mu less than 1. Case 2, light enter into the one medium to second medium with bending away from the normal, away. So sin I upon sin R equal to constant greater than 1, so mu greater than 1, and mu is the refractive index. Keep in your mind. Then total internal reflection. Total internal reflection denoted by TIR. So total internal reflection is defined as light travels from high refractive index to low refractive index. Light travels from high refractive index to low refractive index and angle of incident is greater than angle of critical. Angle of incident is greater than critical angle or angle of critical, only reflection takes place. It's called total internal reflection. Total internal reflection is defined as light travels from high refractive index to low refractive index and angle of incident is greater than critical angle. Only reflection takes place, not refraction. Only reflection takes place is called total internal reflection. And this is the ray diagram of total internal reflection. So from this diagram, we must know about the reflection and refraction. When light falls on the surface, like glass or water, some part of light is reflected in the first media and some light passes in the second media. That is, reflection and refraction takes place. Keep in your mind. This is the origin N2 and N1 initial state, that is first medium, and N2 is the second medium. This is a total reflection takes place. In case of total internal reflection, only reflection takes place. The reflection is the property of light. This reflection is the property of light on account of which the light change its path when it enter from one medium to another medium. In the refraction, light enter from one medium to another medium which change its path. If the light enter from air medium to rare medium into glass medium or glass medium to denser medium, ray bends towards the normal, and if light enter from glass to air medium with bending away from the normal, the ray goes from in two stages in the refraction. One stage away from the normal and second stage towards the normal with bending. Here, total internal reflection consider light rays from a point source yes. This is the origin. This is also known as yes. Yes is the source. Optically denser medium falls on the surface on the other side of which is less than optically denser medium, as shown in a ray diagram. This diagram. For the ray diagram, suppose this A, B, C. They are both reflection and refraction takes place as the interface. And this B, the angle of refraction is 90 degree. Angle of refraction is 90 degree, which means that the refracted ray run along the interface. The rays A and F, or this is the last ray F, where angle of incidence is larger than theta C. So this theta C is the critical angle. There is no refraction and only reflection takes place. In theta C, there is no reflection and there is no refraction, only reflection takes place. That is total internal reflection. When the light falls on the mirror, this ray enter from same medium and to form the reflection or to take place the reflection only, not refraction, keeping your mind. So in the total internal reflection, you remember properly, only reflection takes place, not refraction, keeping your mind. And now the condition of total internal reflection. Number one, angle of incident is greater than angle of critical. Angle of incident is greater than angle of critical. So that is I less than theta or theta c. Theta c is the critical angle. Then first refractive index is greater than second refractive index. So mu1 greater than mu2. I'm sorry here. First refractive index is greater than second refractive index. So here mu1 greater than mu2. This is the two condition, and this two condition is very important for your view of examination. You have to given state the condition of total internal reflection. So first condition in the, I can write this mathematically, condition I greater than theta and mu1 greater than mu2. So here is first refractive index, mu1 is the first refractive index and mu2 is the second refractive index. So first refractive index is greater than second refractive index, and I incident angle or angle of incident is greater than critical angle, that is theta c. So this is the two condition of total internal reflection. And in case of total internal reflection, only reflection takes place when light falls on the mirror and enter from one medium to second medium with bending. So here is only reflection takes place. So students, I stop here. Thank you very much.